Our final group of formulas are called double angle formulas. In Lesson 7.5, we'll evaluate trig functions and determine angle measures using these double angle formulas. Like the sum and difference formulas, we have a measure for sine, cosine, and tangent. And we actually have three choices for cosine. You can expand them in any of the three ways. This will just help you evaluate unique trig functions either by using the unit circle or by creating a triangle. Let's take a look at the example down below. If cosine theta is equal to 5/13 and theta is between 3 pi over 2 and 2 pi, draw a picture and find the three double angle formulas. When you're asked to draw a picture, the first thing you want to do is use your given information to determine the quadrant you're in. If your angle is between 3 pi over 2 and 2 pi, you're going to be in quadrant 4. Let's go ahead and create a triangle in that quadrant. If we just make our xy axis, take your hypotenuse and draw it anywhere into quadrant 4. Then connect it up to the closest x-axis to form your right angle. Since our angle is theta, let's go ahead and label that in the center of our coordinate system. So over here on that left. It says cosine is 5/13. That would be adjacent over hypotenuse. The adjacent side would be to the right, and the hypotenuse is that diagonal we drew in first. In order for us to find cosine, sine, and tangent of 2 theta, we would need to find the length of that opposite side. If we do Pythagorean theorem, I'll just do a squared plus b squared equals c squared. Always keep in mind that our side length could be positive or negative depending on the quadrant we're in. 5 squared is 25, and 13 squared is 169. If we move 25 over, we get b squared is equal to 144. And when we take the square root of each side, remember b could be positive 12 or it could be negative 12, and it just depends on the direction. Taking a look at our picture, if we went 5 to the right and we count down on the y-axis, our side length for b will equal negative 12. Once we know all three sides, we'll go ahead and determine our double angle solutions. The first one we're asked to evaluate is cosine 2 theta. And notice there are three choices for cosine 2 theta. You literally just pick one. All three of those formulas will give you the same end result. So if we start with cosine 2 theta, I'll just pick the top one. It really doesn't matter which one you pick. The first thing you want to do is expand, and we talked about that with our sum and difference formulas. If it's cosine 2 theta, we would say that is equal to cosine squared theta minus sine squared theta. So in this case, we'll take our fractions and actually square them. Cosine of theta is 5/13. We'll take that fraction and square it. Sine theta, if we look at our triangle, was negative 12/13. And then we'll square that answer. If we square 5 and square 13, we'll get 25 over 169. Now looking at that second fraction, it's negative 12 squared. So if we're squaring that negative, we would get positive 144 over 169. Like the sum and difference formulas, you should always get a common denominator in this step. This works out well for us. If we combine the numerators, 25 minus 144 is negative 119 over 169. And that would be the cosine 2 theta definition using this triangle. If we look at the next definition, sine 2 theta, here there's only one choice for us, so that's kind of nice. We don't have to think about which one to use. We'll just expand the sine 2 theta definition. And again, we expand first. Sine 2 theta equals 2 times sine theta times cosine theta. It's just one big product. 2 is just our coefficient out in front, but I'm going to put it over 1 since sine and cosine of theta are both fractions. We've already said sine theta is negative 12/13. Cosine theta was given, that would be 5/13. And all we do is literally multiply straight across. Pretty easy. 2 times negative 12 is negative 24. And negative 24 times 5 would be negative 120. 1 times 13 is 169. And that's it. That doesn't reduce, so that is our sine 2 theta value. Now tangent's going to always be the one that causes the most kind of work-intensive type problems. With that fraction and squaring the denominator, you're going to have to do a little bit of work with common denominators here. Let's start by expanding the definition for tangent 2 theta. It equals 2 times tan theta over 1 minus tan squared theta. Looking at that triangle, tangent of theta is opposite over adjacent. That would be negative 12 over 5. So in the numerator, I'm going to take my 2 and put it over 1 again, and multiply by negative 12 over 5. And in the denominator, we'll have 1 minus, we'll take negative 12/5 and square it. Maybe, there we go. No, not really. Let's fix that. All right, squared that. There we go. All right, in the numerator, 2 over 1 times negative 12 over 5 would get negative 24 over 5. In the denominator, if we do order of operations, we'll square that parenthesis first. Negative 12/5 squared is going to be 144 over 25. So that would give us 1 minus 144 over 25. In order for us to simplify, we would need a common denominator. So I'm going to kind of bring all of this around here to give a little bit more space. We'll keep the numerator for now, negative 24/5. What I'm going to do is take this 1 and give it a common denominator of 25 over 25. Can you guys hear the birds outside? It's so nice out. I had to have the windows open, so I apologize if that's distracting. All right, so if we have 25 over 25 minus 144 over 25, that simplifies the denominator. We'll keep the numerator again. And if we take 25 minus 144, we get negative 119 over 25. This is the point where we have a fraction within a division problem. And when this happens, we're going to apply keep, switch, flip. So here's what we're going to do. We're going to keep 24/5. We're going to switch division to multiply. And then we're going to flip the denominator. 25 over negative 119. And then we've got to simplify. So if we have negative 24/5 times 25 over negative 119, the first thing that'll happen is the two negatives will become positive. And I also notice there's a 5 in the denominator and a 25 in the numerator. 5 reduces that 25 5 times. That just makes less for us to multiply for our final answer. 24 times 5 in the numerator will be positive 120. And then we have 119 in the denominator. And that fraction will not simplify since we cross-canceled prior to the end result. This means 120 over 119 is our tangent 2 theta value. And that's going to be our stopping point today, everyone. Please make sure to submit a picture of your notes for credit.